Hello. Let's continue our discussion about interesting parallel circuits here. And what I want to bring to your attention is that now I've decided to place an LED on the common path. But now we have resistor on this path, we have a resistor on this path. These two resistors are in parallel to one another, and then the end of the resistor is connected to an LED and then to the negative terminal. Whereas on this side, the end of these switches, which are connected to these resistors, are also connected together and then connected to the positive terminal. We can as well prove that right now. So let's pretend we are starting from a series circuit where we have two resistors like these ones. Let's say we're having two resistors here. So make this a little better. So let's say we're having two resistors. So the first resistor, the second resistor, this is just a switch going to our light LED or light bulb, which is basically in series. Let's recall that. There's something interesting I want you to see here. So if we connect our meter, we are now talking about a series circuit. We start with this. You see it's 10.3, 10.2. Now let's take two paths and so that we could put these resistors in parallel. So rather than being end by end, now they are side by side. So this resistor and this resistor are in parallel. And now let's kind of complete our path here using our simple switches. So there we have the connection, and on this side let's have the connection. So we have the first one switch and the other switch is here. So remember again, we have one resistor, we have the other resistor, we have a switch here and here, we have another switch here and here, and these two parts, they come from the same positive connection. They spread here. We have two parts, switches, resistors, two resistors, switches again, going to a common path to our output device. So we have these two resistors in parallel. Now let's see what value of current do we have here now. 1, 2. Check. It's 34.2. 34.2. More than double the initial value. The current now is more than double the current that we had in series connection. Because in series, when the two resistors were in series, we had around 10 point something, but now we're having 33 point something. So it's almost 3 times. Do you see that? This is when we have two resistors in parallel to one another and then connected to an output device. So this means in parallel connection, the total resistance is smaller than the resistance of one resistor. That's why the value of current now goes very high. We have 34, 33 point something. We have two resistors in parallel. But when we have two resistors in series, the current goes down drastically. Let's see again. Take this resistor, put it back here so these two are in series, and measure the current here. See what we have, 8 point something, 9, around 9. So 3 times. When two resistors are placed in series with the LED, the current is 9 to 10. When two resistors are placed in parallel with the LED, the current is almost 30 something, almost 3 times the original value. That is the significance of either connecting things in series or in parallel. Because when we do so, it means when we connect things in parallel, the resistance of these individual components decrease. But when we connect them in series, the resistance, the effective resistance, actually increase. That's why in our homes, light bulbs are placed in parallel rather than series connection. They are placed in parallel because with parallel, the resistance decreases. So we can power as many light bulbs as possible. But in series, the number of light bulbs that we could power is limited drastically. And we have two parts as originally or as initially what we had in the previous video.